my laptop. But you got this much. So let's start off with what we need to know. This is going back to, and I'm gonna try to do this quickly because we got two parts of this, and I just don't know if we can finish both in the time frame. We'll try. But I wanted to start off with this. This is a refresher of what we're doing. So let's go here. I'm gonna take this link. I want to do the physics one. Let me just click here. And like last time, if you remember, we went to, where is it? Physics. And we were in a DC construction kit virtual lab. So I think, do you want me to put it in the chat? Because I think you bookmarked this already in the past. So you want it in the chat, or do you have it already? I guess he's taking a moment. You got it? Cool. All right, so open it up. And if you notice, this is a resistor that is, now this is extra credit for you. So if you share your screen, you have it. I'll give you the participation points. Your score is going pretty much up because you're getting a lot done. So we start with a battery. And much like the problem, if you notice, the circuit consists of 3 resistors in series to a 24-volt battery. The current in the circuit is 0. And how do I open it? Open what? The you want to share and show me what you're doing? I can walk you through it. Okay, so let me stop sharing. So let me see what you got going on so I can help you through it. All right, yep, you click on the play button. No, that's not the, well, there was another one. Yeah, I think you could use that one. There was the live, the virtual lab part. So it's Circuit Construction Kit DC Virtual Lab. Yep. And when you click on that, you hit the play button. It should start. Okay, good. Because that's the one that has HTML embedded. Okay, you're back on track. All right, so I'm going to start sharing my screen. And let's take a look here. Okay, cool. So let me share here. And let me do this. And there we go. So we're going to take the battery, and we'll consider this our 24-volt battery, right? I'm just helping you visualize what's happening before we start the calculations. You have 3 resistors, and you can put them in series because that's what we're doing. The name of this do now today is 3 resistors in series. So I told you before, just like NASCAR, a series circuit it makes an actual loop. That's what a series is in electronics. Parallel, you have different nodes and different connections. So you have, it looks like 3 loops, or not 3, it would look like 3 loops if it was parallel, but we're not doing that today. So I'm gonna start with this resistor and connect some wires to it back to the battery. So I make a path for electron flow, and I'm gonna take another wire because I want you to see the loop, and I'll take another resistor. So we need 3 resistors in total. And this is similar to what we did last time with the switch and some resistors, but we're not going to use a switch. Just want you to see what's happening. So I'm just completing the circuit. I need one more resistor here, and then complete the circuit by just making the rest of the loop. All right, so now you see the electron flow, and when I say flow, it's actually, if you pay attention, they're moving. So are you this far as is with the flow of electrons? Or you said almost? Okay. So you take a moment to do that while I set up our I didn't name my document, so don't forget to do that either. So when you're looking for your document, you can find it. So we have do now, and this is, I want to make sure it's physics. As of, what is that? Today is the 22nd of July, 2020. Okay. And we'll come down. This whole system uses, and whenever you're ready, just let me know. You can share out if you got this far for the participation points. But we're going to use Ohm's law, but a variation of it, because we have to find equivalent resistance. So what's going to happen is, after I do the calculations, what physically happens is all three of these resistors become one. So you end up having a comparable circuit that looks like this. You're done? All right, let me finish this up, and then you can share. And as you can see, I could change the voltage here too, by the way. So let's change to see if it goes up to 24. It goes up to 110. Cool. So we can go 24 volts like the problem says. Right? And then you can set the other battery the same. But essentially what happens is the circuit gets smaller after you do the calculations, because what happens is we'll have one resistor now that'll make up all three of these using this calculation. Okay. And I'm going to do this again tomorrow for first period. So you'll have a little more time, I guess, in computer science to, I didn't need that part, to basically, so that's what it becomes. This is the equivalent circuit. This is a circuit that is originally what it was from the problem. Each of these resistors will be the resistor that you can set it for. And then when we calculate this at the end, you'll be able to take a snapshot of it. But real quickly, I want you to, I'm going to stop sharing. I want you to share what you got so far, so I can move on with the calculations. So let me stop presenting. All right, let's see what you got. So I'm waiting on you to share when you get, oh, you're starting, cool. You said you finishing it up, okay. Okay, you got the hang of it, dude. Cool. Awesome, awesome, awesome. All right, just leave that running, because we're going to come back to it, and we're going to reset all the resistors and the battery levels to match our problem. So resize your screen. You can stop sharing, because there's two parts to this participation. All right, so now if we have time to go over it, I think there's a way for you to save your work on that FetSim too, by the way, so you can pull it back up later. We'll look into that before class is over. So now, if you don't see what I'm doing because I'm not sharing, I'm now sharing. Okay. Okay. So if you take a look, we got what? We have, let me blow this up some so you can see it better. So as I was saying, I typed this in for you. This is what we're going to use. Now, Ohm's law, if you type it in and you want to look it up later, I'll put the link in the chat, is pretty much like this. All right, so you have V equals IR. The I is current, voltage is voltage, of course, and resistance is any resistor in the system. So the current comes into the system when you plug it up or you connect to a battery source. Now, like I said, we're going to use this calculation here, but the resistor is going to be Req. All right. So in order to find the Req, you usually, for a series circuit, you would, for a series circuit, you use the equation. for equivalent. Oh, that's helping me out. Cool. I'm starting to get the hang of Google a little bit. All right, so now when we do this, we can simply put the REQ for equivalent resistance. That's what that is, right? And this is supposed to be subscript, not superscript, subscript. There we go. And I'm going to stop that for a second. So now we got R1, right, plus R2 plus R3, and it can keep going. As long as this is a series circuit, this is how it goes. It gets different for a parallel circuit in terms of the fractions. It'd be 1 over R1, 1 over R2. But because we're doing series, it's pretty simple today. So these are usually subscript. And you just do the same to all these, because that's how you actually write it in physics. I did the wrong one. So take a moment and try to get this down. And this recording will be there. So hopefully by tomorrow we can do part B or finish it up. And oh, here's Danny. Hey, Danny. Let me switch. She's not in the room yet. All right. Hey, there she is. Hey, Danny.
Hi.
You made it. All right. Let me see here. I got to redo the attendance. Let me subscript this one next. And Danny, I'll scroll up so you can catch up.
Yeah. My bad. I was having difficulties logging in this morning.
Oh, yeah. We all had difficulties.
I don't know. I kept saying I was temporarily like disabled or something.
Oh, your SB account?
Yeah, my SB account.
Yeah, I talked to Ortiz. He confirmed what you was talking about.
Mm.
Danny's here. I'm just gonna make you present because I did talk to him about that. We got to work on your account. Okay, so now where we're at, Danny, is this. Me and Isaiah so far. You might want to take a moment to make your header
Okay.
like this. Name your document and put the problem from Edsby into a Google Doc. We're working on beginning solving for today's problem in part A. So what does that look like for us, right?
Mm-hmm.
So now for our system, we need to understand that we use Ohm's law, and this is like in the middle because these are your notes, basically, things you need to use. So we call this strategy, like the book calls it. And this is going to be your strategy. So next is our known and unknown, right? And come over, get us a little room because it can get long sometimes. Now, what is our first known value? Well, they give us the battery, which is the voltage, and that'll be volts is equivalent to what is it, 24? Yeah, 24 volts. Okay, and this is voltage from our equation earlier, Ohm's law. Let me see if I find a link to put it in the chat that you guys can read up on. Is this a good site? I know I used it before. So yeah, this is a good site because I've used all about circuits since I was in engineering school. And put that there, and you guys can read up on it. Uh, yeah, and now come back to this so you can finish working on it. We got that part, and let me put this in here. The mathematical version of what we're going to use for our calculations is IR, and in this case, another way to write that is voltage is equivalent to the current, because that doesn't really change in a series circuit, REQ or equivalent, or REQ. Okay, and I gotta subscript that. Okay, so this is two ways to write it, but To be honest with you, um, we're gonna need this one the most because we got to take this and figure out something else. And there's a little algebra involved into this. So the current in the circuit is also given. That's I. I'm gonna put current, which you would call I, and voltage you would call V. So you can follow the mathematical uh, terminology. And that was what? That was this 0.032 amps. And let's go down and boom. Okay, so now we gotta look at what we are given for our resistance. So R1 is what? Well, this is R1. And subscript that because I wanted to match the equations you guys are looking at above. And then we have R2, which was also given. And the R stand for resistors, so don't get confused. Just like the resistors we saw earlier. Well, you didn't see it, Danny, because you came in a little later, but I'll show real quickly what that looks like visually for you to understand the mathematics part of it. All right, so I got that. Let me slow down here and show what happened earlier. So we got this right here, Danny, is just reviewing real quickly, is what we did to start a class. And this is a series circuit. And I'm going like this because it could be conventionally going the other way with the arrows. But we're going to focus on the electronics way of how circuits flow. All right, so with all that said, you're gonna when you do this calculation here, this REQ, which will be what happens with this one. This will be REQ, but this will be R1, R2, and R3. So, and these are all resistors that slow down the current so you don't catch fire. And you can play with this if you want. I don't know if you have that bookmarked like Isaiah did. I'm gonna put this in the chat so you can
Mhm.
probably open it up and check it
I
out.
probably don't.
You said what?
I probably don't have it. Hold on.
You got the goal of it? What? Every time you talk, I hear you typing too. So,
I'm not typing though. That's the thing.
what's the clicking thing? So, are you able to do like? Did you have an issue or what's going on, Danny?
I did, but yeah, not anymore.
So you did, but not anymore.
Yeah, yeah, huh.
Okay, all right. So you can check that out later because that's a participation point thing where you create these two circuits in that application, and I put it inside of the chat too, where to go in case you did that link. But let's keep powering through this because we got two parts to it, and first period we didn't get a chance to start on the first part. So let's keep going. We got R1, R2. And now it's time, if we've got everything else, I think, now it's time to specify what our unknown values are. So what do we not know about this problem? What is the problem asking us to say it better? So first part A wants you to find the resistance of R3. So part A, we're going to find, what did I say, R3, okay? And that's going to be in ohms. And in part B, we're going to find the voltage levels. This is why part B is going to be so hard, and we got to wait for tomorrow to finish it. I might just change, I'm going to change the date due to tomorrow. You guys can finish this all up because the next one is probably parallel, and then it's going to give you a headache. Well, actually, it's a review for next Thursday's quiz, final quiz. So part B is you have to find, you got two dots there. You have to find um, V1. Let's just put this underneath for part B. So V1 equal to what? in volts. And you gotta do it for all three resistors. So you're gonna have a part, you have a V2, you're gonna have a, oh, that's the wrong button. You're gonna have a V3, and that's gonna be something in volts. Okay, so part B has a lot going on, and I don't think we can get to it because I got to show you how to get REQ here too. Which, let's see if that works. That underneath here, but it's really a part of part B, part A. I'm sorry. So let me put. I got to redo everything. So I'm not. I'm just gonna say REQ here is needed. Take this one and put that there, so we're not wasting a lot of time. And that's going to be equal to some number we're going to calculate. You did it again in ohms. So equal to something in ohms. All right. So let's get started on the algebraic part of part A. All right. So with that said, we want to first figure out what the overall REQ is, because if you look at this, it's saying, hey, what is R3? We don't know that yet. So what we can do is we can set it up to find the REQ, but let's think about it for a second. We're given what? The battery voltage, we're given the current, and with that said, we can take R1, R2, and figure out what the current will be. So take a moment and write this down because I don't want to lose you. Everybody keeping up so far?
Yeah.
Okay, cool. Okay, so let's look at this. All right, this is the problem. We got 287. We at 180, 148.7. How can we start this off? So use the series circuit for the equivalent, I'm sorry, series circuit equation for a series circuit. Oh, use the equation of a series circuit for equivalent resistance, right? You want to start here because what you want to do is copy and put this here. And then put this here. Use a, just put equation for series circuit. And next, you also want to put this tool here I talked about in there. Bring that over. And if you look at this, REQ can be found if we do some algebra, and then we can go back and find R3. So this is a bit of a puzzle problem. So let's begin, and I want to take my time with it because it can get confusing if you lost a step. So let's start with what we know. We know current, right? And we also know our voltage. So we can use some algebra on this part to get this part and find R3. All right, let's begin. So I'm going to take use equation for a series circuit. I didn't finish typing that because I was trying to copy the right equation for you from above, and my keyboard got stuck. So now use the equation for a series circuit. to find, um, use the Ohm's law. That's what I'm trying to say. Equation for series circuit to find equivalent resistance, right? Or known as REQ. Parentheses, so you know what I'm referring to. Sounds better. REQ is usually calculated if you have all resistors by just adding them up and getting it, but we are missing R3. So let's try to find REQ and then come back and find R3. So you're going to use Ohm's law, which is this here. Turn it off again. And what do we got? Well, if we take this again and do some algebra on it, we can say, hey, clean that up. Hey, let's do some algebra. So let me space it out. What I want is REQ by itself, right? So I'm gonna make a division bar, because you see the REQ is multiplied by current. So the reverse of current is, of course, division. And the reverse of, sorry, multiplication is division. So I'm making my division bars. And where are we at? Where are we at? There we go. And I want to get rid of the current next to the REQ. So I'm gonna divide by current. Why is that small? What happened? So small. All right, let's make all of these 12. And I think the problem with this down here is it's subscript. Let me try it out now. Let me see. Yeah, it's subscript. All right. Turn that off. What is your issue? All right, better. And I'm going to take this over here. And that becomes that. So these are the changes, like we always talk about, right? This is how I changed the above equation for equivalent for Ohm's law with equivalent resistance inside. Okay. Now I'm gonna just move this. I'm gonna cut that. No, I'm gonna leave that there. Yeah, leave that there. It didn't go back. Oh no. There we go. And I'm gonna take this and strike it out, because this is, what? Let me copy this, because I keep wanting to skip steps, but I want you guys to understand what's happening. And there we go. And what crosses out is this current down here and this current up here with that multiplication sign, because that's not going to multiply everything, because it's going to be I divided by I, or current divided by current. That's going to be 1. So go back to strikeout. Beautiful. Okay. So now we have a new equation. Let me turn all this off. I don't know if you can see it. REQ is going to be equivalent to the voltage divided by the current. And these things were given. So I turn strike through off. Okay, now if I come down 1, there we go. So it's going to be REQ and that is going to be equal to, I keep doing that. I'll be trying to just start typing. Turn that off. There we go. Is equal to our voltage divided by the current. And the reason I typed it all the way out, because all we're going to do is go above and use these values. So let me take this again. And I should have specified now, use algebra. Use Ohm's law equation. And right about here. Now use algebra to solve for REQ or equivalent resistance, right? All right, so we got that part. And this goes to bring this down one. That goes with the top portion. There we go. That looks a lot better. Okay, so we got that. Now we're going to plug in our values. So current was what? Well, that was our 0.032 amps, 328 amps. And our voltage was, I think, 24. So now, when volts and amps come together, volts is divided by amps, that makes ohms. So let's take this. And the amps are going to go away. Some parentheses. We're going to use symbol lab, just calculate it out. And that's going to be divided by this number. So this becomes ohms. That's our REQ for the moment. But our goal is to go back and find R3. So, because that's what the problem was asking us above. Okay. As you can see, I have to do part 2 tomorrow, which is why I'm giving you guys till tomorrow to finish this. So what do we got? Well, we use this bit here, and then we take this value and calculate what the ohms are. So if I come here and I say, hey, symbol lab, and then I say, well, hey, I want to calculate that, which is 24 divided by 0.0328. I get a yield of, let's see, yeah, sure, 731.7, let's say that's 71. So that's going to be 731 point. It's a lot of resistance, eh? And it makes sense if you put all the resistors together. And that's ohms. Okay, so that's not the end of it. Now use the equivalent resistance found above. Blow this back out to solve for what do we say, R3 via algebra, or utilizing algebra. All right, so how do we do that? Well, if I come back, remember, this is the equation for equivalent resistance, and it's set up that way because we have 3 resistors, right? It could be 4 or 5, 6. But as long as it's a series, this is the equation you'll use. So I'm going to copy this, come down here, there, and this is the resistor that we want to find. It wasn't given in the problem. So I'm going to put that in like a hard purple, and just know we're looking for that. But we know some other things. We know REQ, we know R1, and we know R2, or resistor 1, resistor 2, and the overall super equivalent resistor. So now we just got to find the missing resistor. Like, it's on the system, but we never measured it. We don't know what it could be, but we're going to find out using math. So turn it off, and I'm going to come down here. You got to rewrite the problem one more time to start on our algebra for it. It's a real simple algebra process because everything's either adding or subtracting in this situation. I don't see nothing dividing or multiplying real quick. So what I want to do is get rid of R1 and R2. And I'm going to do this in one step. I hope you can follow. But I want to do this so R3 is by itself. And I know I have REQ here. I'm just going to bold that and I'll highlight it. I'm not underline it because it's not the final solution. It's part of what we need to get to our solution. So what did I say? I'm gonna turn that off, and instead of just R1 being there, I'm gonna say, hey, it's positive R1. I'm gonna subtract R1, and I have to also subtract R2. So what I get is, once I fix this up, so it looks the same. This is like doing a painting. All right, and all of this, these are the changes. Okay, so don't get that confused. R3 is what we're looking for. So what will happen is you did this on this side to get rid of R1 and R2, but what you do to one side, you have to do to the other. So I'm going to take this and I'm going to put it over here because I got to make sure it goes to the other side as well. And is that subscript? Yeah, it was. And so now we have a new situation. And take this down and then show what crosses out. So you guys can have all that. Guys and gals, I should say. All right, so what changes here, right? Well, we know that these two will cross out with these two. And that plus sign will go away too. So I'm going to strike this out. And then I also have to strike out this part. All right, so now we have a new equation where R3 is by itself because these two elements canceled each other out, but they're by algebra they ended up over here. It's opposite. So let me come down. And our new equation is going to look like REQ, I'm sorry, R3 is, I'm gonna go here, just rewriting it for you guys. Equal to this part here. And now we have what we need to get R3. That was the hardest algebra part, and I did that before. You got to go in 10 minutes or 11 minutes. So let's finish it off, and then we'll pick up on this tomorrow. Make sure you type all this up because tomorrow we're gonna pick back up on this, and then we'll have one additional problem to work out for review. So let's put the numbers in and get this out the way so we can get you ready for your next period. So I'm gonna take this. Oh, what the heck happened? Come back. Take this. Supposed to copy. Put that there. And now we put the values in, right? Now remember, you got to pay attention to the fact that you got negatives on here. So those go with the calculation. So what is R1? Let's go back up. R1 was 287.5 ohms. So that's R1. All right. Don't forget it's negative. Then R2, what? Let's come back up to our unknown and unknowns. That was 148.7 ohms. Okay, so that goes here. And lastly, REQ, we found that a moment ago, right? So I'm gonna put that in parentheses too, so the negative affects it. What I'm doing is put the numbers in. I'm not changing the equation we made up here, right? Those negative values will affect how this calculates because they're all important. So REQ, well, we found that to be this. Okay. So all that's going to combine as like terms, ohms, ohms, ohms. They're just all going to be ohms. All right, and I want to make that in black. So now when I put it together, I'm just going to rewrite it all and get it ready to calculate. and that goes here. So we end up with a new calculation of all the ohms becoming just 1 ohm. All right. So I should do this to make it simple for was it my symbol lab? Yes, 7 there. I thought I killed too many numbers. That's what I did. And then let that go. Let that go. Because essentially all this will become ohms. Okay. And I got to put the negative in there too. It'll mess up the calculation on the outside. Okay. So I think we're ready to put it in symbol lab and get this problem over with. So I'm going to take this portion and get it ready to solve for the final part. This is only the final part of A. We got to go back and do V. And then we'll have one rehearsal problem for getting you guys ready for the quiz and discussing grades. So what does that look like? Change view on this. And I want to ask Symbol Lab, hey, what does all that jazz become? So I put it in there. Will it work that way? Let's cross our fingers. It looks like it will. And our answer is 295.51 ohms. So that's all of part A. I want you to take a moment, type all this up. The video again will be pretty much shared out in Edsby around about I want to say 2:30, 3 o'clock. What was I trying to do? I was trying to make sure all the fonts were the same. There we go. And that's clean as clean as clean. All right, all right, all right. Okay, cool. So about a 2-page document. All right, so I think that's it. If you want to see how to get this much type up, I suggest you check out the video. But it's 6 minutes till class is over with. You guys are free to head to your next class. Do check out the video. Do be in class tomorrow. This assignment will be due by tomorrow, 8 p.m. Okay. So that's it. Let me turn the recording off so I can get ready for processing.